We're going to build a very basic third-person controller, and we're going to use this opportunity to learn how the new Unity input system works. The controller is going to have two modes. This is shooter mode, where the character always rotates in the direction that the camera is facing, and when the character moves, he strafes. All right, this is what you want in a shooter because you always want to be able to shoot where you're looking. But we're going to add an extra little mode, which is really simple. We're going to have an adventure mode. And in adventure games, movement is slightly different. What happens in an adventure game is when the camera rotates, the player doesn't rotate. So you can go down and look at your player, if you like, from all angles. And when you move and turn in the direction of the movement instead of the direction of the camera. So we're going to do those two things, but the real focus here is learning how to use the new Unity input system, which I'm going to explain and work through in the easiest and simplest way possible. All right, let's jump right in. So this is the scene that I've set up. I've used some free Unity assets from the asset store to make the scene. Let me take you through those really quickly. I've used the Polygon starter pack for the main character, which is the Bean Cowboy, which I think is an awesome name. I've used the Gridbox prototype materials, which I really like just to add color and to keep track of the dimensions of my scene. And I've used the Fantasy Skybox for the skybox in the back. Now with that in play, I've also added some post-processing to make the scene look a little bit better, which I have to do because I'm making a video, obviously. And if you watch any YouTube, then you know that Unity YouTube videos are all about bloom. Yeah, they're all about bloom. But for now, we're going to set this to 0.1. You don't have to do any of this. You can follow along with the tutorial if you just use a flat surface that you can call ground if you like, and you can use a capsule collider. I've just made this so it looks good, and I've added a compass at the bottom here, which is just pointing forward and pointing right along the axis of the character, so that as I explain how the input system works, you can follow along in the scene with the way that the character is facing. I've also installed a couple of packages already, so you don't have to watch me do that. I've installed the Cinemachine package. I don't yet have a Cinemachine camera in the scene. We'll do that together. I've installed the ProBuilder package, which I use to set this up. And I've already installed the new Unity input package. When you install the new Unity input package, which you do from the package manager here in Windows Package Manager, it's going to ask you if you want to restart Unity to enable the new input settings, which I've also already done, but I haven't done anything else regarding the setup, right? So we're going to do all of that setup together off the basis of the scene. First, I just want to talk about the new input system a little bit abstractly. If this confuses you or you get lost, don't worry, we're going to do each of these things one by one. So the Unity input system, the new one, basically starts by creating an input action asset. And an input action asset contains input action maps. An action map is just a named collection of input actions. So you can have an action map for any action that could take place while you're in the UI, for instance. So action maps contain input actions, and then input actions really consist of two parts, right? Every input action has a binding or more than one binding, and a binding is what connects an input action to a control, to an actual analog control. So you don't have to remember this diagram. I'll put a link to the diagram in the description if it helps you. I just want to, before we start, say we're going to create an input action. It's going to contain multiple action maps. Each action map is going to contain a collection of actions. Each action is going to have one or more bindings. And we're going to do this in the easiest way possible. So let's go here. I've activated the new Unity input system. Once you've done that, the first thing to do is to create an input action, an input system settings file. So I'm going to go to Edit, project settings, into input system package, and it says here settings for the new input system are stored in an asset. Click the button below to create a settings asset. I'm going to create settings asset. Now, what the settings asset does is it allows me to specify default values for what counts as an input for me. How many seconds does the player have to hold something down, hold a button down for it to count as the button being held? How much pressure does he have to put on a button for the button to count as being pressed or started? It's good to have these settings a little bit separate so that you can save them in your project and reuse them if you want. I'm going to take this file here in my project window and dump it into my input folder inside my settings folder. I already have a settings folder because I'm working with a universal render pipeline project. You don't have to do that. You can work with the default render pipeline if you like. I'm trying to only work with the universal render pipeline because I'm trying to learn how it works really. So this is a URP project. Right. We've created our input settings file. Now we're going to create an input actions file. What's this guy called? Input actions asset. That's what we're going to create. So to do that, I'm going to put it in my scripts folder just for now. You can decide, of course, where you want to place it. I'm going to right click, create, and in here we've got it's over here somewhere. It's the pressure. There we go. We've got input actions. Unity recommends that you call this new controls, so I'm just going to call it controls for lack of imagination. This is my input actions asset, and I'm going to go over here and hit edit the asset to start creating some input actions. The first action map that I'm going to create, the only action map we're going to use, is going to be called the gameplay action map. So the gameplay action map is going to contain actions that the player can execute while the game is running. This would be separate to, for instance, if we created a UI action map. Imagine you're playing a multiplayer game that doesn't pause when you go to the UI menu. So the game is still running, but you don't want the player to be able to input actions for his character or gameplay actions. So what you would do is you would disable the gameplay action map and enable the UI action map. All right. I'm not going to use this UI action map for now, just the gameplay action map. And the first action we're going to add, as always, is the move action. Now, move, the type of action that it is, it's going to be a value, standard, and it's going to be a vector 2. All right, the move input's going to be a vector 2 because we have a vertical and a horizontal axis, which can both be positive, negative. So you can think about it as an X and Y axis can have positive and negative values. Now, an action needs to have a binding, which connects the action to the control. And here, we can just listen for a binding, right? So if I go here to listen, it's listening for an input that can give a vector 2. Now, the thing about this is that there's no single key on my keyboard that if I press it, and you can press a bunch of keys here, if I press any of the keys on my keyboard, none of them is going to register as a vector 2 because there's no single key press that can yield a vector 2. However, if you have a controller, like I do, I'm just powering it up, a controller does have an input which can register a vector 2, which is the analog stick. So as soon as I move the analog stick, it pops up there saying left stick, and that can be my control that is bound to my move action. If I want to bind a keyboard input to my move action, I have to use what's called a composite binding. And what a composite binding does is it takes multiple controls, in our case multiple keys, and it maps them to one control. So it mimics a new control. So I can go here, I want to add a binding, but the binding that I'm going to add is a vector composite. I'm going to call it WASD, into up, we're going to go to the path, listen to W, make a W on the keyboard, down, path, S, I want to make it S on the keyboard, left path is A on the keyboard, and right path is D on the keyboard. I've got two bindings connected to one action inside my one action map, inside my input actions asset. Don't forget to click save asset so that this thing works. It doesn't save automatically, you have to click autosave. And now we're ready to go. We've set up the top of this input period here, but to use the input action map, we actually have to enable it in a script. So what I could do is use this controls as I have here and just go use the mono behavior components that come with the new input system. But I actually want to do this all in code so we can see exactly how everything works and we can customize it ourselves. So I'm going to click on generate C# class, which is going to generate this controls class, hopefully in the same folder. Yeah, there we go, in the same folder. Now I can use this controls class in my own code. So let's do that. I'm going to create a script here, a C# script, and I'm going to call it input controller. And off we go. I'm going to open Visual Studio. Now, the input controller is going to be responsible for reading the inputs, right? So it's going to have a member which is of type controls, that new class that I just created. So that type controls, all right, there we go. And do I have to activate it equals new controls? Do I just get this guy automatically? It's a good question, I don't remember. Well, we'll do it in a second. So let's go on enable. Well, let's go when we wake up. I want to create a new instance of that controls asset. So let's go controls equals new controls. And I'm doing this inside my awake method because I use the awake method whenever I want to set up something specific to this class. Anything that this class, the input controller class, has to do for itself, I do in awake. And when I hit on enable, I want to start enabling my action map. So let's go here. Now we can look at what the action maps are. And I should have one called player. Sorry, not player. I should have one called gameplay. There it is. And I can go enable. Now I've enabled the action map and I can start listening to the actions themselves. Now how does that work? Well, I've got another little piece of my diagram over here. Each action has 3 callbacks that you can subscribe to. So what's that saying is for each action, there are 3 points that you can listen for. When the action starts, that means when the key is pressed. When the action is performed, depending on your input settings, you actually dictate what counts as being performed, how heavy the key press has to be or how long the key press has to be. Then the action is going to register as yes, we have successfully performed this action. And then finally, when you let go of the key, you're going to get cancelled. So to each of these 3 states, you can add listeners, stuff to do when those input action happens. And they're going to pass in what's called an input action callback context. Let's take a look. So I'm here. I want to register. So I want to go to controls.gameplay. There's an action here called move. And when it is performed, I want to do something. Let's call this guy on move. Let's call this guy, yeah, I think on move should do it like that. Doesn't need, of course, it's delegate, it doesn't need an input system here. Now it says I haven't declared this method just yet, and because I can never remember what the syntax should be, I just go generate this method so that I get the correct input over here. I'm going to get an input action callback context, which I'm going to call context. All right, so when move is performed, it's going to call this function. And the thing that we want to do is we want to go to we know that we're getting a vector 2. Let's call this move input. And we're going to read it from the context. We're going to read it from the context.read value, which is of type vector 2. And now, whatever my input action press was, is going to be read into my move input vector. And for now, all we're going to do is we're going to go debug.log. Let's make it a rich text, a little script there, a rich text string. This is a new feature of C#7, I think, C#9, I don't remember. So from here, I'm going to say move input. And what I want to print to screen is that vector, move input. Okay, that's all that we want to do. Everything is saved, but we haven't attached this mono behavior to anything in the scene yet. So let's create an empty game object, which I'm going to call game manager. And normally anything that's controlling, that's a center for control inside my game, I'll attach to my game manager. And in here, I'll put my input controller. Okay, let's fire up the console. Oh, sorry, these are from previous things. Let's fire up the console over here. No, don't make it maximized. Stop. Let's go to the game window. Don't make it maximized. Fire up the console. Now if I press W, I get a move input 0, 1. Negative -1 if I press S, left, right. Interestingly enough, on the gamepad, the default is not digital normalized. So I'll just talk about that in 1 second. These are my gamepad inputs as I swirl the gamepad around. So when my move action is being performed, I'm getting that input pumped straight to my console. That's a good start. I just want to say something about those values. Over here, if we go to edit asset, move, WASD, the mode here is digital normalized, which means that for each axis of the vector, digital means that I'm only going to get a value of 0 or 1 or 0 or -1. That's the input that comes in. Normalized means that if I move forward and right at 1 and 1 as hard as I can, right? I'm pressed W and D, both of them down as hard as I can. I would get 1 in the forward direction or in the vertical direction and 1 in the horizontal direction. The problem with that is the magnitude of a vector that's 1, 1 is larger than 1. The magnitude of a vector that's 1, 1 is actually square root 2, which is about 1.4. That means that if I don't normalize this input, when I run diagonally, I'm going to run faster than I move forward and backwards, which is not what you want. And that's why those Doom speedrunners in the first Doom, they only move diagonally because the input's not normalized. Okay, we have an input controller, we have some controls. The input controller is just reading in the input into that vector, move input, but it's not doing anything with it. Now, I want to make sure that my input controller is disconnected from my player. And what I mean by that is I want my player to be able to be in the scene without there being an input controller and without anything breaking, or I want my input controller to be in the scene without there having a player, which we already have working, right? Input controller's in there, a player is in there, but the player is not doing anything with the input controller. So to make that work, I'm going to create a Unity event, which is going to respond to this onMove. Okay, and as a matter of fact, I actually want to call this guy onMovePerformed, and we'll talk about in a second why. onMovePerform. Cool, that's all done. Now, I don't know about you guys, but I can never remember the syntax for Unity event, and I thought about editing this out, but I think it's better to actually show you what I do when I program, which is I Google things like this. Oh, I think it's this one. So I Google this, and what I'm looking for is this guy. And remember that serializable requires using .system. Let's do that. Let's delete all this guy. Boom. Why is this guy complaining? Oh, it has to be Unity engine.events, I think is the... It does say in that... There we go. Is it events or event systems? No, it's events. Cool. What I've done here is create a public class, my own class, which is a Unity event. It inherits from the Unity event. But you have to do this if you want to use Unity events that take inputs. Unity event can take up to 4 inputs. I'm going to take 2. One's going to be a float and the other one's going to be a float. And we're going to call this move input event. And when we get a move input, what we're going to do is we're going to go move input event dot invoke. Not dot invoke. Oh, I got to clear. Sorry. Why can't I do that? Because I've declared the class, but I haven't declared an instance of the class. So we go move input event, move input event. That's all good. Now we go here and we go move input event dot invoke. And what I'm going to pass the event is my move input.x and my move input.y. Now, why do I do this? Well, now, when I've created something that wants to respond to the move input, oh, that has to be public. And we'll see why now, because I want it to show up in the inspector over here. Yeah. Now if I create a class that has to respond to the move input, I can go call the functions from that class here in the move input event in the inspector. So if nothing is listening to the move input, that's not a problem. But if my player is in the scene and it listens to the move input, I can add it or disconnect it here. So let's go get the player moving around, right? We've handled the input system. Let's connect the input system to the player. I'm going to make a new C# script, and I'm going to call a player controller. I'm immediately going to add it to my player here. I just want to show how I like to set up my player. This compass is just that thing at the bottom there. But I like to put the mesh underneath something called mesh and then put all of my components on the player parent game object so that I can swap the mesh in and out later, right? Which I like to do. And then I'll put my animator components on top of my mesh game object over here because that's mesh specific. Got this player controller. We can add component player controller. And then let's fire it up. Dun-dun-dun. Nothing is happening. Let's create 2 float variables that are going to hold my vertical and horizontal input. And then, like every player ever, let's create a public variable. Yeah, let's make it public. Let's make a public variable, which is also a float, which is going to be move speed. Now this speed is going to be in the metric system as meters per second, and the person working in the inspector is going to be able to edit this move speed. It's going to show up because it's public. Now, where am I going to get my vertical and horizontal from? Well, I'm going to create a function here called private void. No, it has to be public. Public void on move input. And it's going to take 2 floats, vertical and float horizontal. Right. And all it's going to do is take those two things and assign them to the private variables that I've created here. This dot vertical equals vertical, and this dot horizontal equals horizontal. Right? Now, when does this function get called? Well, it doesn't get called inside here ever. It gets called as a response to the move event that we've set up. So if I go in, wait for it to save, go to my game manager. When this move event happens, right, I want the player game object, which has the player input controller on it, to call the function on move input. That's what's going to happen. So now, inside here, these floats, these floats are going to be passed up to the event. The event is going to call this function and pass in the two floats. To check that that's all working, let's put the same debug statement inside the player controller, but just mention that here we are player controller, move input. All right, let's call this, we're going to split it into two, vertical and horizontal. Okay, now if everything works as is, go to the console over here. Let's clear that out. As a matter of fact, let's turn off the other one so we don't have too many inputs here for now. Too many stuff being output to the console, I mean. Let's press play. Press the button, there we go. Buttons are coming into the player controller. Now the reason I did it this way is the player doesn't care if there is an input controller in the scene. If I delete the input controller, nothing's going to happen. And the input controller doesn't care if the player's in the scene. If I delete the player, all I have to do is this guy will go empty, basically, and I can just subtract this event where I'm listening to the event over here. Now, if you're smarter than me, then you'll have seen here there's one problem with this, with the setup that I have right now. It never gets back when I release the key. So if I press the key, I might press, this is left, I think, or down. I might press down and I get -1, 0. But it doesn't get another event until I press another key. Now, generally for input, that's not what you want. You want to know when the person presses and when he stops. Because I want my move vector to be -1, 0, and then I want my move vector to become 0, 0 again. Right? I don't want it to stick as -1, 0. That's problematic. And the simplest and most straightforward way to do this is to go back to our input controller over here and just subscribe to the cancel callback. You guys remember those callbacks that we had? Subscribe to the cancel callback, because that's when he lets go. So I'm going to go to controls, .gameplay, .move, .cancel. And the really nice magic here is I don't need a different function. Because what I want to get on the cancelled callback is I want to get the value 0, 0, right? That's what I want. I want the vector to be 0, 0. But when he releases the key, the vector becomes 0, 0. So I can subscribe to exactly the same event. Sorry, I can give the same delegate performed. Now let's debug that over here. Let's clear it up. I'm just going to press one key. So I'm going to press forward, and then when I let go, I get 0, 0. Great. Now I'm getting all the input events I care about passed into my player controller. Let's do some movement. I'm going to again try and do the movement as simple as I possibly can. Let's not go there. Let's have a Visual Studio autocomplete the update for us. What I'm going to do here is I'm going to make a move direction vector, which is vector 2, because my character can't move. Well, it can't move vertically up into the sky. I'm going to call this move direction. And it's going to be equal to, it's actually going to be a vector 3. Right. Yeah, it's going to be a vector 3 even though he can't move vertically. I'm going to vector 3.forward times, which one is the forward one? Well, it's vertical, plus vector 3.right times, which one is in the right direction? Well, that's horizontal. This is just a direction, right? Because it's normalized. A vector 3.forward is always the vector 0, 0, 1. This is the global vector 3.forward. If I said transform.forward, that would be something else, which I'm not doing over here. So if I want to take a direction, but what I want to get out of it is a total movement, right? I have to move the movement speed. But movement speed is in meters by second. So I want direction, then meters by seconds, meters per second, and then to get rid of the seconds, I have to multiply by time. So, transform dot position plus equals, I'm going to update my position by this amount, my move direction, which is just the direction, doesn't have any magnitude, its magnitude is 1, multiplied by my move speed, multiplied by time dot delta time. Remember, meters per second times seconds gives me back meters, which is what you want. Public float move speed, let's give it a nice default value. That's all good, I think. Nice default value. Yeah, that all seems fine. But keep in mind that if you change the default value there, it doesn't change it over here because I have already added the script. If I added the script to the game object afterwards, it would set the default value over there. Now, moment of truth. Okay, I have added those in the wrong direction, but the guy's moving, which I'm pretty happy with. And I've added those in the wrong direction because vertical comes out first, then horizontal. And I've done, sorry, here, input. This is horizontal, not vertical. That's vertical, but I should keep it the other way around. It should obviously be X before Y. Let's go back here. This guy should be X before Y. Here we go. Now if we go back and we press play. Okay, now if I press forward, he goes along his own forward axis. If I press back, he goes along his own back axis, right and left, right and left. Now, you can see that his forward axis right now is aligned with the world forward. How can you see that? Well, that's the world forward over there. It's aligned with his forward, and his right is aligned with his right. It's in no way relative to the camera, right? The camera's forward axis is pointing at this guy. It's pointing from, let's see if we can see the camera. There we go. It's pointing from there down like that. That's the camera forward. So he's in no way moving relative to the camera. We have to do that next. And he's only moving along the global forward and the global right. So what we have to do is we have to change the move direction so that it's relative to the camera. Does that make sense? So I need to know how much rotation do I need to rotate this forward until it is pointed along the camera forward. That's the one thing that I want to do. But there's one little extra step, right? The camera forward is pointing as a line like that. Let's actually see if we can get a better look at that. Yeah, sort of. The camera forward is pointing at a line like that. It's pointing down into this plane. But that's not the forward that I want to take. The forward that I want to take is the part of the camera forward that's on the plane. So not this one, but rather this forward projected onto where the plane is itself. Now luckily Unity has functions that do all of the stuff for you. Okay, so let's first go get the camera forward that's projected onto the plane, and then let's rotate enough to line up with that camera. And I'm not going to rotate the player, I'm going to rotate the move direction. So let's go get the camera forward. So I think it is vector 3 dot projected camera forward. Let's fetch the camera forward. It's camera.main dot transform dot forward, and let's project it onto a plane, which is a function that comes with vector 3. Project on plane. Take this vector. What is the normal to the flat plane? Well, it's the vector that points straight up, right? All right, that's the camera forward. That's the line that lies on the plane but points in the same direction as the forward vector coming out of the camera. Oh, there we go. The blue is the forward vector coming out of the camera. Now, with this camera forward, I need to rotate my move direction so that the forward of my move direction, which is the global forward, lines up with this guy, right? And how do I get that? Well, let's declare a quaternion, which is what we're going to use to represent rotation, and call it rotate to camera, rotation to camera. And again, quaternion has a really kind of cool function, which is this look rotation function. Creates a rotation with the specified forward and upwards directions. So I want to rotate until I'm aligned with the projected camera forward. And my up is going to be up. That's it. Oh, well, vector 3 dot up. that all? Why don't you like that? Projected camera forward. There we go. And now, before I move, let's move right at the end of the update. Before I move, I'm going to rotate my move direction to be relative to the camera. And the way to do that with a quaternion is you pre-multiply the vector with a quaternion. So we go move direction is equal to rotation to camera times move direction. Okay, let's take a look at that. Now, let's align our game view with the scene here, with the camera here. Align view to selected. This is the way the camera is looking. So now what I expect to happen is if I press forward, I expect to move forward along the camera direction, which would be into the screen. And if I press left or right, I expect to move left or right relative to the camera, which would be across the screen like that. Let's see if that is indeed what happens. Excellent. Up and down, in and out of the screen, left and right, in and out of the screen. All that remains for us is to handle the rotation of the player. Let's get the player rotating. Now the way I want the player to rotate is to face in the same direction as the camera, and I already have the rotation that's going to make that work for me. So let's add a public field called rotation speed. It's going to dictate how fast the player can rotate. This is in degrees per second, and I happen to know that a good value for it is about 280 for what I want to demonstrate here. And now I want to change the transform's rotation. Previously, I was rotating the move direction itself, but now I want to change the transform. And I want to use this function called quaternion.rotate towards. And the reason I like this is because it allows me to avoid doing things like lerp or slurp. Quaternion.to, the target I want to rotate to is the rotation to camera, and the max degrees is going to be my rotation speed times time.delta time. I think that's all you need to now rotate to look in the direction of the camera. Let's go check this out. What have I missed here? Oh, I've got transform.rotation. Let's go look over here. Now if I press play, keeping in mind that the camera is facing that way, I expect the player to rotate to face that way. And now I've got shooter movement up and running, which I'm pretty excited about. The next thing that we have to do is build the third-person camera itself. And we're going to do that with the Cinemachine free look camera. We're going to immediately name it Cinemachine third person. All right. And what we're going to do with the Cinemachine third person camera is we're going to make it follow the player, but I don't want it to look at the player. I always want it to be offset a little bit. And for that, I like to use a look target. So I'm going to create an empty object here called look target. And I'm going to put it at about 1.5 is fine. Cinemachine 3 third person, it's going to be its look target. Let's go to the game view to check out how that camera is sitting. The field of view is a little bit small for me, so let's make it 60. That's a bit better. I want to invert the y-axis, but I don't want to invert the x-axis. And now it's really about adjusting the radii and heights of the different rigs that you're going to move between as the camera moves up and down. I think a good height for this is probably about 4.5. Yeah, that's okay, which will make this 5.5. Let's make this 1. Let's make this radius 6. And I experimented with these a little bit before just to get a feeling for it. Let's say that's 2, maybe 3. And now we can check by adjusting the y-axis value, going up and down. That's actually okay. That's fine for this. Let's make this back to 0.5. Now, a Cinemachine camera is not going to work with the new input system out of the box. Okay, you need to add a component which is called the Cinemachine input provider. That guy over there, and it's going to look for an action, a new input action, that's going to move the camera around. And we don't have one of those just yet. So let's go to our controls and add one. I'm going to add a new action, and this action is going to be called look. It's going to be a value, and it's going to be a vector 2. My first binding is going to be my right stick. Oh, hit listen. It's going to be my right stick. And my second binding is going to be my mouse delta. Let's go to path, mouse delta. Okay, now the camera should be able to move around. And don't forget to save asset. Well, I still have to assign this inside the Cinemachine camera itself. Let's go there. Boom, boom, boom. If I click on XY axis, let's click gameplay look. I don't want to have the camera selected. Now, I should be able to rotate my camera using the mouse. Aha! My player rotates to face my camera, moves forwards, he moves backwards, and he can strafe. Video's almost done. I just want to add the ability to do one thing, which is to add the adventure type to our controller, which is I want him to rotate in his move direction, not rotate in the camera direction. And the way to do that is as simple as everything else we've done so far. I got the rotation to a camera in one way, and I'm going to get the rotation to the move direction in exactly the same way. We declare a quaternion rotation to move direction. I can only do this after I have worked out the rotation, the new move direction. Let's do that. New move direction is going to be quaternion.look rotation. Move direction and vector3.up. I think I can leave the vector3.up out and it doesn't make a difference. There's a version of this guy that only does takes 2 inputs, but I'm not going to check that now. And now instead of rotating towards the camera forward, I'm going to keep this here, but I'm just going to comment it out for a second. Instead of rotating towards the camera forward, I'm going to rotate towards the move direction. Like so. And I think that's our adventure controller. Let's go take a look. So now camera rotates, but this guy doesn't rotate. And as soon as I move, aha, that's what you want to see. It rotates in the move direction, but not in the camera direction. That's our adventure controller done. Thank you so much for making it all the way to the end of the video. I really hope that this made the new input system a little bit easier to understand than what it was for me. If you've made it this far, you really just have to pat yourself on the back. I love third-person games, it's my favorite genre, and I love third-person controllers, and I love making games. So in our next video, which will take probably about a week from now, we're not going to use the controller we're built now. We're going to use a much more sophisticated controller that's free on the Asus store. I'm going to show you how to set up that third-person controller for your needs, and then connect it to a state machine to manage the animation. So I hope to see you then. I'm obviously on YouTube, I'm on Twitter, and myself and the Fluxinator have started streaming on Twitch as well, so you can check us out.